Hello to all the viewers. This is Dr. IJ Raghavendra, initiating online lecture series on operations research. Today we are going to discuss about northwest corner rule of transportation problem. Here the given matrix consists of three factories and four destinations. The capacity of three factories are shown under supply column, that is F1 equal to 120 supplies, 120, F2 equal to 180 tons and F3 equal to 165 tons. The demand of four destinations are shown under demand row, that is D1 100, D2 150, D3 115 and D4 100. And the middle of the table represents cost matrix. For example, F1 D2. Here it is 8. What is 8 here is, so if we supply from factory 1 to destination 2, it costs 8 rupees. That is 8 rupees per kilometer. So if it is 1,000 kilometers is there, 8 into 1000, that is 8,000 rupees. So these are all represents a cost factors. To solve any transportation problem, first we may check that the given matrix is balanced problem or unbalanced problem. How can we know that it is a balanced or unbalanced? Simply, we have to equate total supply is equal to total demand. So the total supply is 120 plus 180 plus 165 is equal to 100 plus 150 plus 115 plus 100. So here the total is 465 and here also 465. That means it is represented as a balanced problem. There is no change in the matrix. So now how to solve this problem is, once we may know the directions that is east, west, north and south. But the name represents, it is represent northwest corner. So always search for northwest corner direction of this table and we can easily solve this problem. So in this case, what is the northwest direction of this table is, it comes under F1 and D1. This is a combination. We may select the cell like this. F1 total is 120 and D1 total demand is 100. So F1 has plenty of supply, but D1 requires only 100. So we may supply 100 only. So if I supply 100 to the D1, there is no more demand of the D1. So it represents 0. It will become a 0 and F1 supply will reduce it to 20. And here D1 total demand will become a 0. That means there is no more demand to the D1. So it is not possible to F2 and F3 to supply to the demand. For that purpose, we may not consider these cells for the next level of calculation. And now the matrix is reduced to 3 rows and 3 columns. Out of this, again we need to search for northwest direction. Here F1 D2 is having a northwest direction. And see, F1 total is 20 and D2 total is 150. So here F1 capacity is only 20. F1 capacity is only 20 tons, but the demand is 150. So F1, based on the F1 capacity, we may supply only 20. So now the F1 will become 0 and here all 150 is the demand, but we supply 20. The additional demand is 130. So F1 total supply will become a 0. That means F1 may not supply to D3 and D4. So we may not consider this D3 and D4 of F1 for the next level of calculation. And the matrix is reduced to 2 rows and 3 columns, F2 and F3, D2, D3 and D4, out of which we may identify the northwest direction. Here this is the northwest direction, F2 and D2. Here F2 total supply is 180 and D2 is 130. So we have plenty of supply, but the demand is only 130. So simply we can supply 130 only. So that means we fulfill the demand and F2 total supply may reduce it to 180 minus 150, 130, that is equal to 50. So here D2 demand is 0. That means F3 may not supply any additional thing to the D2. So that's the reason we need not consider this cell for the next level of calculation. The table is reduced to 2 rows and 2 columns. Again, this is the northwest direction of this table, F2 and D3. And now F2 total supply is 50 and D3 is 115. D3 is 115. So we may supply only 50 here. So 50 will become a 0 and 115 will become 65. So F2 remaining balance is 0. So it is not possible to F2 to supply product or additional thing to the D4. So that means we may not consider this for the next level calculation. And now the table is reduced to 1 row and 2 columns, out of which, so this is the northwest direction of the table, F3 and D3. F3 total is 165 and D3 total demand is only 65. So we may supply only 65 based on the demand. So now D3 total will become a 0 and 165 will become 100. And the table is reduced to only 1 row and 1 column. Here we may select this table. F3 total is 100 and D4 total is 100. So simply we can supply 100. So 100 will become 0 and here also 100 will become 0. And check that if there is any cells are left over or not. So all cells, there is no cells are left over, and now the problem is solved here. And now we have 6 allotments are there, that is F1 D1, F1 D2, F2 D2, F2 D3, F3 D3 and F3 D4. So after completion of this, again we need to check that whether it is a degeneracy problem, degeneracy or non-degeneracy. By using this formula, m plus n minus 1 is equal to number of allotments. So in this case, or not. So m plus 1 and m means number of rows. So 3 rows, how many columns? 4 columns minus 1. And now how many allotments? 6. That means 6 equal to 6. So that means this is a non-degeneracy problem. So there is no additional modification of this to this table. So we can easily calculate the total cost of this problem. So total cost is equal to, by simply multiplying the allotment into the cost, that is 100 into 5 plus 20 into 8 plus 130 into 11 plus 50 into 14 plus 65 into 9 plus 100 into 7. The total is equal to 4075. Now we reach to the feasible solution. Thank you and all the best.